the power of slope-intercept form and what information it gives us. Or when we have information, we can write equations from this. So keep that in mind as we do these last few examples. Excuse me. A second wireless company. So remember, Lenore was looking at hooking up her tablet computer to their wireless company and figuring how much it costs. And we came up with, it was, if we go back, 30 cents or 3 cents per minute, and initial value of 10 cents. So here is a second wireless company. Unlike the first company that Lenore was considering, this second company explicitly states its access fee is 15 cents. You're going to pay that fee no matter what. That's our initial value. Okay, we're starting from there because even if you use 0 minutes, you are paying 15 cents. That's where we're starting from. And then its usage rate is 4 cents per minute. That right there is your slope. So the cool thing is that it's giving it to us here, but if you have this information, you can write an equation, okay? Because, and I'm actually going to change it here, because in this case we have b plus mx. And you know what? It really doesn't matter. Our initial value is whatever's being added on, whether it comes first or second. And our slope, our rate of change, is whatever number is attached to the x. So it says let x represent the number of minutes and y represent the total cost. Construct a linear function that models the total session cost based on the number of minutes used. And that sounds really, really confusing. Construct a linear function. Write an equation. Okay? So if y is the total session cost, we say y equals, well, our access fee, our initial value, our b of 15 cents, plus our rate of change, our slope, which is 0.04, 4 cents per minute. Since it has that per, that's why we're multiplying by x, which is the number of minutes. Guess what? Okay, so this y here, that is our total cost. So it says up here, and this x right here, that is our minutes. So when I run and do a table down here, the number of minutes, remember, that's our x values, our inputs, and the total cost is our y values, our outputs. So in this next part here, now that we have our equation, it says using this linear function, using this function, this equation, you can determine the total cost, the power of the equation. We can figure out what the total cost would be if you go talk for 0 minutes or 10 minutes or 20 minutes or so on and so forth. Okay, so all you have to do is type this stuff into your calculator. And I'm going to go through it quickly. I'm not going to show you the typing in the calculator part. So if you need help with that, make sure you let me know. This right here, all I'm going to do is I am going to take this value right here and I'm going to plug it in for my x. So I'm going to say y equals 0.15 plus 0.04 times 0. Well, of course, that's going to cancel out, and I'm left with just 15 cents. This is the last one right down here. I'm going to do 15 cents plus, now I'm going to put in 10 for x. 0.04 times 10. And that works out to be 55 cents. And if I did this for all of them, this would be 95 cents. If I input a 30, we're down to $1.35 our total cost would be. For 40 minutes of talking, our total cost would be $1.75. 50 minutes would be $2.15, and 60 minutes would be $2.55. And again, guys, that's just plugging these inputs in for x and solving for y. Basically typing the numbers into our calculator, our function into the calculator. Okay, so now it says plot these points on the original graph in exercise 1. So this graph down here is what we had at the beginning. This was the first company. Okay, so this line right here is first company. And now we want to plot our second company. And I'm getting too fast with my writing again. Okay, so this line right here is our first company. Now remember, it's not coincidence that we have x's and y's and inputs and outputs in their table because these are ordered pairs. And so I'm just going to take each of these points and I'm going to plot them on the graph. So 0 to not moving left or right at all, up to about 15. Remember, that's going to come just above the 10 cents that it was in the first company. Then we have 10 and 55 cents. So that's going to be just over, remember this line is a 50 cents. 20 and 95 cents, so just under the 1 minute. Sorry, the $1. 30 goes with 135. So 125 would be halfway in between. I'll move up a little bit. 40 would be 1.75, so that's going to be halfway between the 1.5 and the 2. And 50 is going to be at $2.15, so about in here. And 60 is going to be at $2.55, so just over the 50 cents. Okay, so now, does this look like it's a linear function? Does it look like it's a straight line? Yeah, okay. So we're going to draw a line through it. And notice I'm not including the negatives on this because the negatives don't make sense. It doesn't make sense to have a negative number of minutes or a negative cost, okay? Let me put second company here too. Let me try to spell it right, though. Okay, so we have our second company and our first company down here. In what ways does the line that represents a second company differ from the one that represents a first company? Well, the second company costs more. At any one of our minutes here, their cost is going to be higher. Any of them, okay? If we just think of the graph, we're going to say the second company, the line is steeper. Okay, when we talk about lines and slope and rates of change, the line is steeper, which is why it costs more. And if it's steeper, if it costs more, then we can say our second company. These are all different ways of basically saying the same thing. The second company's line has a greater slope. Or rate of change. Remember, rate of change and slope basically mean the same thing. Okay, so looking at that graph, it's easy to see, instead of giving paragraphs of information, it's easy to see that, hey, I want to go with the first company. At no point should I go with the second company. Maybe unless they give me something free, but usually not. All right, let's quickly just look at one more example here. A band will be paid a flat fee for playing at a concert. Okay, there's that initial value. Okay. Additionally, the band will receive a fixed amount for every ticket. If 40 tickets are sold, the band would be paid 200. If 70 tickets are sold, the band would be paid 260. So, then how much money they get is dependent on how many tickets they sell. That means that the tickets are my X values, my independent values, and the cost, what they get paid is our Y values, is our dependent variables. Okay, so the reason I point that out is it says determine the rate of change, that's slope. Okay, so let's make this into two ordered pairs. So I can say 40 tickets, they're going to get paid $200, and 70 tickets, they're going to get paid $260. X value, Y value, X value, Y value. Now, it didn't say up here to make it into order pairs, but it's asking us to find the rate of change. If I want to find the rate of change, which means the same thing as the slope, I can use my slope formula. And this is something I already know how to do. Difference in my Y's over the difference in my X's. I make one my first point, I make one my second point, and I plug this in. So Y2 minus Y1 is 260 minus 200, making sure our Y's are on top. And then this x2 minus x1 will be 70 minus 40. And I get 60 over 30, which just equals 2. Okay, so our slope, our m, is 2 because it's always going to come back to that slope-intercept form. Okay, so let x represent the number of tickets sold. Already done it. Y represents the amount the band's going to receive. Already done that. Construct a linear function. Here's that crazy talk again. To represent the relationship. All that means is write an equation. Construct a linear function. Write an equation. And that's going to represent this relationship between our tickets, X, and our how much the band gets paid, Y. So we have our M. We don't have our initial value though. It says they're paid a flat fee, but we don't know what that is. But think back. Remember, use what we've used before. We have a point, and I'm just going to use this one here, 40 and 200. This is an X value. This is a Y value. Plug it all in. So my Y here, and I'm going to come over here, is 200. That equals my M, which is 2, times my X, which is 40, plus B. Okay? So I'm just plugging all this information in. Okay, and you could have used the other point, doesn't matter. So this is 200 equals 2 times 40, which is 80 plus B. And since we're solving for B, I'm going to subtract 80 from each side, and I'm going to get 120. B equals 120. So now if I have my M and my B, I can write my equation. Y equals 2 times X, M times X, plus B, 120. So now, keeping in mind that Y is how much money they're going to get, and X is the number of tickets sold, what flat fee will the band be paid every night? Initial value, 120 bucks. That's where we're starting. How much will the band receive for each ticket sold? Well, right here, this is the number of tickets. They're getting $2 per ticket. So again, guys, that's the power of understanding that writing this linear function is really writing an equation. It's really slope-intercept form, and just knowing all these different terms and how they go together can help us make the problems a lot easier.